Alright, gentlemen, it is time for me to quit fucking around. We have things to do and the year is almost over. I still don't have my 16-bit ISA proto boards from FutureLec. I was going to try to finish that darn project before the end of December so that I could make hashtaggery, but that's not going to happen. When you order stuff from Thailand, well, Thailand is good for certain things if you're a connoisseur, if you know what I'm saying, but it's not a good place to order electronic components from, so don't do that. My mistake. But we'll get it done eventually whenever the shit gets here. In the meantime, we've got Model 2s, TRS-80 Model 2s to do fun stuff with. I also finally got myself a constant current power supply. It looks like it's been in somebody's septic tank for 100 years, but this is a 6216A HP constant current power supply, or constant voltage, depending on which position you put the switch in. This one's from the late 60s. It goes from 0 to somewhere around 25 volts. I don't know if it works. I don't know if the magic smoke will come out if we try to make it work. But as you can see, it does need some work. So that's going to be a project for us. Yay! So I was taking a gander around the flea bay and I saw this thing, an old, mostly missing stuff, TRS-80 Model 2. But oh goodness, other than one crack in the back. And no siree, that's not the kind of crack you'd be a connoisseur of if you were exploring Thailand looking for your fucking proto boards. It's in a whole lot better shape than that pile of junk over there that got all smashed up in shipping. So we've got some work to do, boys. We're gonna have to take some stuff out of that and put some other stuff out of that into that. And then still have some stuff from that goes into that and fix the keyboard and all of that fun stuff. And it's going to be a great project because let me tell you boys, the TRS-80 Model 2 is the best computer for the hardware-minded old computer connoisseur. And I'll tell you why. The design, since they weren't trying to save money, that was an expensive son of a bitch back in the day now, let me tell you. I think it was $4,000 in 1978. Ho ho ho! I don't even want to speculate as to what that would be in 2020 bucks, and it'll probably be even more after we have hyperinflation 2021 bucks. Boy, oh, wait on that. Anyhow, the reason, so they didn't cut any corners when they were doing the design on the thing. There are a couple of little bits of funny business, like I/O ports, the same I/O port being shared between, different devices on the same card. But aside from that, it's a very straightforward design. It's the technical manual is one of the best technical manuals that I have ever read. I mean, it explains everything in an understandable fashion. It's great. And so a fella with a TRS-80 Model 2 can run TRS-DOS stuff, you can run CP/M stuff, you stick 68K card in the son of a bitch, you can run Xenix stuff. But as we have discovered, they're awfully fragile. Yes, easily turned into junk by the shipping monkeys, which is a shame because it makes the good old TRS-80 Model 2 not very accessible. They're hard to find, and when you do find them, they get smashed before you get them. But, boys, you know how my big ideas go. They usually never come to fruition. But it seems to me like it wouldn't be too difficult, considering how straightforward the circuitry is, to build your own TRS-80 Model 2. Using modern components, you could reduce the chip count a whole shitload, especially if you use static RAM. That would be pretty darn sweet now, wouldn't it? You wouldn't have a case, but of course we have AT form factor cases. We could make our cards a little bit shorter than the stock cards, but in such a way that they would still fit in the stock TRS-80 Model 2. But we could make them a little shorter so you could also make yourself a little backplane that would plug down into an ATX case, and you could put all your stuff in there and have yourself a TRS-80 Model 2 built out of a kit, probably for less than $150 if you sourced parts from skinky Chinese electronics scalpers. but sometimes you got to do what you got to do, I guess. And you'd have a wonderful machine that you could learn a lot building, and it would already have existing software that you could run on it, because a lot of the problem with these microcomputer trainers is you build yourself your little breadboard computer, and then you're like, well, okay, I built it, now there's no software to run on the thing, other than to flash the LEDs and make the game of life and echo shit on the serial port and stuff like that, you know what I'm saying? But Z80 machine like the TRS-80 Model 2, you'd have all that TRS-DOS software, you'd have all that CPM software that you could run right off the bat. Additionally, the suckers are very expandable. You can make yourself a 68K CPU card in the future. Start running Xenix on the thing. And you wouldn't have to stop there. I mean, this is bigger brain stuff than my dumbass is capable of. But the Amiga guys have figured out how to implement 68080 cores in FPGAs. Think about that. You have your 68080 core on an FPGA on a card that works very much the same as the 68K card that runs Xenix on those things, but then boys, then you boot Linux on the son of a bitch. Then you've got a real computer running a modern operating system that you can actually do modern stuff on, as well as all of the fun old stuff that old computers are nice for. And as you built and added this stuff to your kit machine, you'd be learning stuff in digestible chunks all along the way. And that's why I'm so enthusiastic about the TRS-80 Model 2, even though I bought my first TRS-80 non-DT. I had a DT1 hooked to a Linux machine when I was in college, but my first actual computer non-serial terminal TRS-80 was in 2019, and that was only for the aesthetics of the Model 4. But the Model 2, when I found out about those, I said to myself, Lee, you gotta have one of those. You gotta turn it into a 16, you gotta run Xenix. Maybe someday we can run Linux on it. Sweet. Let's have a read of the technical manual. If you're one of short attention span or not a complete TRS-80 Model 2 zealot, this will probably put you to sleep. But let's have a nice read of the technical manual and see if I'm full of shit or if I'm onto something. Because honestly, I'm not exactly sure. You tell me what you think. Here it is, boys. TRS-80 Model 2 Technical Reference Manual, catalog number 264921. This is a great manual. I mean, even if you don't have a Model 2, I think it's an excellent read from an educational standpoint. I learned a shitload just reading this thing. It has all of the different modules listed. I don't have... This is the older floppy disk controller that's in here, and I actually have the revised floppy disk controller, but that's alright because we've got technical documentation for it too, and all the errata and all of that stuff. So I think the memory board will be the easiest thing to make our own of. They made two memory boards that were the same. One of them just didn't have as many chips, but one of them had 64K and one of them had 32K, and I believe this one right here is the 64K board. We can see all the RAM over here and a bunch of other shit over here. It's probably for generating refresh and stuff like that. That's a delay line right there, I believe. I wasn't sure what that was the first time we looked at it, so I looked it up. They're using a delay line, I guess, to do the make the memory refresh cycles happen at the right time. That's kind of old school, but I guess when you're from 1979, that's how you roll. So let's look at this thing and see how it works, shall we? I'll just set this aside. Memory board. So these are 16K by 1 bit ICs here. So it takes 8 of them to get a byte. So that's 16K, 32K, 64K. Voila, right? And the memory on the Model 2 is arranged into this banking scheme. It's arranged into 16 different the manual calls them pages. It calls each particular board, you can have more than one of these in a system, it calls each particular board a bank, which is a little weird. I've got to remember to call it pages so if you're reading along here you don't get confused. The TRS-80 Model 2 arranges all of its RAM into pages. There are 16 different pages of RAM. Page 0 is always, each page is 32K, and page 0 is always in the lower half of the Z80 CPU's memory map. It's always in there. Well, it's not in there when the ROM's mapped in there, or at least part of it isn't, but that's for another time when we look at the CPU card. Most of the time when you're not booting the machine, page 0 is always in the lower 32K. Now the upper 32K can be switched between the remaining 15 banks. So obviously, if you've just got one 64K card in the machine, your 64K is going to be taking up the whole 64K Z80 memory map all the time, and there won't actually be any bank switching going on. But with 16 possible banks of each 32K each, it's actually possible for the TRS-80 Model 2 to address a total of 512K of RAM, which is pretty fucking respectable for a machine of its age. The upper 32K page is selected by writing a 4-bit nibble, 0 to 15, into the, I think it's the lower 4 bytes of I/O port FF hexadecimal. And when you write a 0 in there, it actually unmaps that upper page of RAM. I wasn't sure about that. I had to seek help about that on the VCF forum because I'm dumb, and I appreciate whomever it is that clued me in on that. I don't remember who off the top of my head, so I apologize for that. But when you write a 0 into that page select port, it actually unmaps the upper 32K, which doesn't seem very useful. Don't know why they did that. If it was me, I'd have made it mirror the lower 32K, because you might be able to do something clever that way. Somehow, maybe. Let's look at the schematic a little bit. Oh, and also, when you write to the highest bit, bit 7, the most significant bit of I/O port FF, it unmaps the upper 2K of whatever page is paged in at the top of the Z80 memory map. And the reason for that is because the video card also watches that I/O port, and when you unmap that upper 2K using that high bit of I/O port FF, it maps the 2K video RAM into that space off of the video card, so you can do direct VRAM access. But that's a discussion for another time when we look at the video card, which probably won't be for a little bit. But yeah, so let's look at the schematic here and see how difficult it would be to implement our own, right? It looks kind of complicated just looking at it. Fortunately, the schematic's only one page, but here's our array of 32 or 64K of RAM using 16K by 1 DRAMs. And those DRAMs take some weird-ass voltages. Old RAM takes like -5 volts and 12 volts and all kinds of volts. It's fucked up, man. But modern RAM, most of it'll just run on 5 volts, and in this day and age you can get a whole Alliance 512K by 8 static RAM for about $5. So that's pretty good. That would fill the entire TRS-80 Model 2 memory map right there. There's our 512K. Well, one of those chips will be 512K, and that's static RAM too, so it doesn't require refresh, which is what a lot of this shit is. So here are all of these chips, we can replace with one of these chips, so that's pretty sweet. And here's all of the memory refresh circuitry, I think, over here. That would all go away using static RAM. This down here, this little NAND gate, this 8-input NAND gate, does the I/O port decoding for that I/O port that switches the memory page in the upper part of the Z80 memory map. And some of this shit up here decodes this part right here decodes that unmapping the top 2K, I think, and some of this stuff up here. This is a, no, it's not a flip-flop, it's an 8-bit register. Latches that port data on there, and then these decoders over here select the RAM on the card if it's assigned to a particular bank using the jumpers. But we wouldn't make our own card like that. We would still use the 8-bit register, but then we just add those 4 bits to the address decoding. To the address lines on our RAM chip, so that would work transparently. We'd have to have a little bit more logic to map out that top 2K so that the video RAM could be mapped in, but we could do all of that. Instead of using discrete gates, we could very easily do all of that with like a GAL 22V10 or something like that, or maybe a couple of them. We could probably do it with just one, but there we are. I think that this whole card can probably be replaced with 2 ICs. Am I missing something? I don't think the GAL ought to be able to do that latching, and it'll probably take 2 of them actually, because we'll have to do address decoding too. We'll use one to latch the port data. And do some of the decoding, and the second one to do the rest of the decoding. So 3 chips. 3 chips to implement a 512K RAM card for the TRS-80 Model 2. So that sounds like it would be an interesting project, doesn't it? Perhaps we should do that one of these days once I get the Model 2 fixed up. I like to get ahead of myself, don't I? So that's kind of cool. So yeah, that could work, I think. So that's not outside the realm of possibility. I think the next easiest thing to implement our own of is probably the CPU module. And I know that sounds complicated, but the Z80 actually is pretty easy to interface to stuff, and the Model 2 uses other chips in the Z80 chipset to do a lot of stuff, so it's they weren't trying to cut corners by bodging cheap stuff together. It uses all of the appropriate chips that are designed to interface with each other. So here's the CPU card. It has the clock and timer on it. It has the DMA controller on it. It has the CPU on it, and it has a serial I/O chip on it, because there's a serial port built into the CPU card. And my initial thought was it'd be nice to just, when we make our own CPU card, it'd be nice, since we're only going to be using, like 3 chips for RAM, we could build our 512K of RAM onto the CPU card and then have the serial port somewhere else. But and then the rest of this stuff is just, like 74 series glue logic, and we've got some 1488 and 1489 serial line level converters up here. Those I don't think they're made anymore. Maybe somebody makes them, but they're still readily available, but they're obsolete. I think if we made our own implementation, we'd probably use like a Max 3232 or something like that. They're still in production. We want to try to use chips that are all still in production, of course, because that makes everything a lot easier. You don't have to be sourcing as many parts from cheesy, shady places on the interweb. Oh, here's our port allocation list. So, clock and timer chip, serial IOs. Okay, so none of those ports on the CPU card are actually shared, so it would be possible to move the serial port onto a different card. Let's just flip through here and look at stuff. There isn't much said But what is said, I mean, it tells you what you want to know without a bunch of bullshit, and it's easy to understand. It's a wonderful, wonderful technical manual. So there's a ROM on here. I think it's a 2K ROM. Might be a 4K ROM, but anyway, there's an I/O port that you write a 0 or a 1 to, I think, the least significant bit to turn the ROM on and off. So when you've got the ROM mapped in, it maps in at the very lowest. It maps in at 0 in the Z80 memory map, because that's where the Z80 begins execution on reset. And when the reset signal is received, whether it's power on reset or a manual reset, the ROM has to be mapped in down there magically by the hardware. That can, of course, be done with 74 series logic or our magical 22 V10s, which solve all of our problems. Yay. And then there are just some other ports that shit gets latched into using some flip-flops, and I think the SIO and the CTC have their own registers on board that store that data. I don't know, let's look at the schematic and see what it looks like. Oh, look, here's a schematic. How many pages? It's a 3-page schematic. Well, that's not too bad. Okay, so here's our CPU. Not much to that, it just attaches to the bus, same as everything else. Our DMA controller basically just attaches to the bus. It's got some other shit down here. It looks like there's some IRQ interrupt stuff that goes into the DMA controller, some DMA request lines, and a non-maskable interrupt. So no big deal there. A lot of just regular logic there. They're using tri-state buffers for this. It must be part of a chip that they weren't using all the gates on. But look how they did this. Like some of these 3 gates and the buffers in the chip are always on, so they don't act like tri-state buffers. And then this one up here, look how they tied the tri-state line in with the input. So I guess that kind of turns it into an open collector buffer. So that's interesting. I would have never thought to have done that. I would have wasted a whole chip just to have an open collector buffer like that. So that's kind of cool. So here's some more line drivers. LS240s there. Here's an LS244. That's an inverting line driver there. So the address lines, that's interesting. The address lines on the Model 2 bus are inverted. Huh. Well, isn't that something? Huh. Now here's the ROM. It's a 2716, so that is a 2K ROM. But the ROM page is like 4K. Maybe they made it so they could upgrade the ROM to a 4K ROM later if they had to, and never did. I don't know. This stuff down here is the clock generator. They're not using a clock divider chip. They're just using a series of flip-flops to divide that. What is it? An 8 megahertz crystal? Where's the crystal? Y1. Pardon me. I've got the coof. Fuck. Oh, yep. 8 megahertz crystal. So they divide that down to 4 megahertz and 2 megahertz and 1 megahertz, I guess. Or actually, no, I did that backwards. It goes this way. So that's interesting. What do we need a... Oh, the 1 megahertz clock's used by the CTC, apparently. Okay. That's interesting. Some jumpers to do some stuff that I don't understand. Just looking at it, I'll have to go back and read about that. So, it's interesting, too, that it looks like they just used a crystal, a bare crystal, and some support logic instead of using a resonator can. So, if we make our own, we could probably simplify this a good bit by using a resonator can and like actual clock divider chip. And I think since we'd be using static RAM anyway, it might be interesting to put the clock generation on its own card, along with the reset circuitry, because then that card could be replaced with another clock generator and reset card that also implemented some kind of fancy blinking lights front panel with run stop switch and like single stepping and shit like that, because that would work with the static RAM. We wouldn't lose the contents of RAM when we had the CPU wait stated indefinitely. So that would be kind of cool. Yeah, that'd be kind of cool, wouldn't it? I believe it would. What's on the next page, boys? There's the clock and timer chip. It hooks to the data bus. Nothing too crazy. That's the SIO chip breaking out to the serial port with our line level converters out here. So that's pretty straightforward. What do we have here? An S182. What the fuck is a 74-182? What is a 74? 74-182. That is not something you see every day, is it? Or does it say 132? No, that's definitely 182. U23. Look ahead carry generator? What the hell are they doing with that? That'll require... Oh, they're doing something with DMA there. I'll have to read about that. That's kind of funny. That's kind of funny. Are there any other weird-ass chips here? Line low converters, mask grumps, blah 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 stuff. BCD to decimal decoder. That is not BCD to decimal decoder. That's U36. Where is U36? Maybe it's on the next page. We'll look at that in a little bit. So here are a bunch of flip-flops. 7474 is just a flip-flop. It's not a latch, but they've connected just two 7474s mouth to ass here to make them into a latch instead of just using a latch. Well, was there no 7475 chip in 1978 or something? Isn't that what they did? Yeah, it looks like that's what they did. That is a little strange, boys. That is a little bit funny. Huh. Okay. LS145, is that weird motherfucker? Yeah, that's what that is. There's BCD to decimal decoder. Oh, okay, so it just takes 4 bits in and selects like one of 10 outputs. Okay, I was thinking it was something different, like a 7-segment display decoder. I'm stupid as shit. So those must all be open collector outputs since they've all got pull-ups on them there. But they've all got pull-ups on them, so why did they, well, I guess that's what they used. So, yeah, that's just, okay, they're just using that for address decoding. For some IO, for those IO ports, for the different, like the DMA and the SIO chip and all that stuff. Okay, so that's kind of strange, but I guess it makes sense. Here's some legitimate tri-state line drivers, 8726s. I don't know why they didn't use LS245s there. Maybe the LS245 didn't exist in 78 or something, but that's no big deal. We'd replace that with an LS245. And again, here's a bunch of, address decoding logic using discrete gates. So that could all once again be rolled into gals, 22V10 gals. Very good. So this is a little more complicated than the memory card, but oh, here's the reset stuff down here. Yeah, so yeah, that's nothing too outrageous, I don't think. I was afraid they were going to be using an RC circuit for power on reset the way the Model 4 does. But it looks like they didn't cut corners on the Model 2, I guess. I think that's eminently doable, and at the you know, the 4 megahertz speed that something like this would be operating at, you know, the design considerations wouldn't be nearly as stringent as you know, some kind of high-speed chip. So yeah, I think building our own CPU card and you know, building that 512K RAM into it is probably eminently doable. I mean, it's not too complicated. I would probably be neat to use like an electrically erasable PROM. And we could probably jigger that up some way so that it could actually be programmed in system. I mean, the kit builder would still have to have, you know, a working ROM to begin with, to get the machine booted, to like write new ROM images, right? But yeah, it'd be easier to do it like upgrades, you know. I don't know why anybody would ever want to change the ROM, but I guess, you know, like, if somebody made some hot shit like 68080 card or something, you might have to have something a little funny in the ROM to support some other stuff or something. I don't know. So I mean, that would be like a couple of extra lines and a couple of pins on a gal somewhere. I mean, I don't mean to make it sound too trivial or anything, but it's not. It'll be a project, but it won't be. It's not outside the realm of possibility, I don't think. It's eminently doable given the time and dedication. Excellent. So the 2 cards that we have left that we'd have to implement to have a working TRS-80 Model 2 are, I think, will be a good bit more complicated. This is the disk drive controller, and this is the keyboard and video controller. And I think the keyboard and video controller will definitely be the more complicated of the 2, so let's look at that later. And for now, let's look at the disk drive controller. Now, I've got a thought on this. The disk drive controller is entirely I/O port driven. There's no, well, now wait a minute. This is the revised disk controller. It may, I think the old one's all port mapped, but the revised one may use DMA, and that may throw a wrench into the works. Hang on a second, I need to do a little bit of reading. The revised floppy controller is basically exactly the same software-wise as the original, except you can reset it in software if the disk drive hangs up, but other than that, everything's exactly the same. So it is all port mapped. So I've got this thought that may be crazier than a bag of dicks, but hear me out and tell me what you think, right? So the TRS-80 Model 2 uses an 8-inch disk drive, which is cool as fuck, especially since like the spindle motor runs on like wall current. That's epic, fucking epic. But working 8-inch media is almost as hard to find as a wife that I can tolerate, right? And so anybody that's going to be using a Model 2 is probably going to be like hooking up a GoTech or an HXC or some kind of floppy drive emulator to the floppy controller board, right? Rather than using actual floppy media, right? So that being the case, there's a lot of extra translation going on there, right? The floppy drive controller, the port mapped floppy drive controller in that case, gets controlled by the software through all of these I/O ports, and it turns all of that shit that goes into those I/O ports into these specially timed shit, you know, that goes out over the floppy drive cable, and then the floppy drive emulator like clocks in all of that specially timed shit and turns it back into bytes and stores it on a fucking CF card or something like that, right? So there's all this shit in the middle that it's like the same shit comes out, pretty much the same shit comes out the other end that goes into the one end, but there's all this complicated shit in the middle that complicates and then uncomplicates things again, alright? And so that stuff's not really necessary if we're not using actual floppy disk drives, right? I mean, I'm sure some of us do want to use actual floppy disk drives, and, you know, in that case, maybe it would be kind of cool to make a clone revised floppy controller if those, you know, are difficult to find. But for most users, I don't think they're going to be using actual 8-inch media. So for the floppy drive controller, I think that, like, it probably wouldn't be terribly difficult to take like an Arduino or something like that, which is kind of cheaty because a frickin' Arduino is going to be like orders of magnitudes more powerful than the actual CPU, this actual Z80 CPU of the machine, so that's a little funny, but you know, you gotta do what you gotta do, I guess. So we could take an Arduino and hook it up to all of the port decoding and latching logic on the floppy drive controller, right? So the software would talk to this Arduino, which would look like the floppy drive controller to the software, right? And the Arduino would just take the data off of those ports and reconstruct it into like tracks and sectors within its own memory, and then just write them into a disk image file, right? And you wouldn't have all of that intermediate shit, turning stuff into analog signals and then back into digital signals or whatever the fuck you'd have to do to, you know, when you actually hook a floppy drive emulator to a floppy drive controller, you know what I'm saying? We'd have the whole kit and fucking caboodle in an Arduino. You just have some I/O ports that you'd write to, and the Arduino would take care of the rest of it. And that I think would be eminently doable. And here's something else that I think is kind of interesting. This floppy drive controller chip that we'd be emulating with the Arduino, it's a Western Digital 1691 on the revised controller, and the chip supports sector lengths of a maximum of 1K, so 1K sector length maximum, okay? And and then each disk can have a maximum of 255 tracks, and each of those tracks can have a maximum of 255 sectors. Now obviously there's no actual physical floppy media that has that many tracks and sectors. I don't think there are any that actually use 1K sectors either. But I mean, like, a virtual floppy drive emulated inside of the Arduino, that would be with 255 tracks, each containing 255 sectors, which were each 1K. That would be 64 megabytes, right? That's like hard drive sized. And if we had a 68K card in the machine, if the Xenix installation floppies will allow you to install it to a device on a floppy controller, that would completely alleviate the need for a hard drive controller, which would be significantly more complicated than this, I think. So I don't know if that would work. I've never even gotten my Model 2 to boot. This is kind of crazy territory, right? But if you think that would work, let me know. I think that would be eminently doable. I mean, the schematic looks fucking complicated, but that's just because there's all this unnecessary stuff that we wouldn't need, because we wouldn't actually be talking to any disk drives, right? So, and finally though, the frickin' video card and keyboard controller. That boys would be the most complicated thing to implement our own of. Because obviously we don't want to be driving a CRT with it, because the whole point of this idea is to make the Model 2 more accessible to more people, because you just can't ship them without them getting smashed, and there aren't that many out there. But they're so cool that they should be more accessible to people. So in that line of thought, I think that the video and keyboard controller would be something else that would be an excellent candidate for cheating with a microcontroller, with an Arduino or a ESP8266 or an ESP32 or something like that. Something like that. Actually, it'd be pretty interesting to use an ESP microcontroller for the floppy controller, because then you could connect it to your NAS or something with Wi-Fi, or run like an FTP server on the floppy controller over Wi-Fi and just copy your disk images to and from the thing from other computers transparently. That would be sweet as fuck. That would be sweet as fuck. Yes. But anyway, I'm getting off track. So, I think the most straightforward thing to do, I mean, as far as like making it accessible, I think would be to have the video and keyboard controller, like from a software perspective, look like the original controller, but instead of outputting to a monochrome CRT and using a parallel keyboard, it would just use a USB keyboard and output like VGA or something. And there's some libraries out there for bit banging monochrome VGA with Arduinos and other microcontrollers. So that would probably be a workable solution for getting video output. And of course, you know, it's very, very easy to plug HID devices into these microcontroller modules. I mean, a lot of them already have a USB port on board that you can just plug a keyboard into and, you know, do some configuration in your software, and it'll just use the keyboard as a HID device and work. You know what I'm saying? Of course, we'd have to figure out how to translate between IBM or IBM AT scan codes and whatever the fuck the Model 2 expects to be latched into the keyboard I/O for it. Let's flip over to the video and keyboard interface section and see what it has to say. No, that's the video monitor, video keyboard interface, page 55. 55, boys. Where's your 55? Here it is. Okay, so, oh Jesus Christ. That's a block diagram in 3/4. Let's just turn the, oh God, look at that timer. Oh God, my head's hurting already. 6845 CRTC. Yes, I see. So, the CRTC, I think it only, I'm pretty sure it only really does timing and like memory cycling shit for output to through a character ROM. It doesn't actually do video generation. It generates sync, but the video signal has to come from somewhere else, according to my recollection. Okay. Okay, so the CRTC connects to a number of I/O ports, Yeah, okay, here are the I/O ports. And then the keyboard does too. So the same as we would do with the floppy drive, we could just, latch data off, on and off of these I/O ports, and then have the Arduino synchronizing with that and reading shit and doing stuff. But the real ass clincher here is, recall before that the system allows us to unmap the top 2K of RAM and map the video RAM into it. And when you're doing memory cycles on the Z80, I don't think you can use wait states with memory cycles on the Z80. Only with I/O cycles. So the Arduino, or whatever it is, in that case wouldn't be able to make the CPU wait for it to have valid data on the bus. It would have to be fast enough to act like RAM, and I don't know how realistic that is. I mean, if we generated interrupts on the Arduino pins, and used a good efficient interrupt handler whenever it needed to read or write to that video RAM, we might be able to do it with a fast microcontroller. But I don't know, man. If the timing wasn't like right on every time. See, there's another thing about the video controller that I had to seek some help understanding on the VCF forums, and that is when you map the video RAM into the Z80's address space, that top 2K, the CPU always gets priority access to that RAM. And the video hardware generates an interrupt whenever the vertical blanking interval begins, so that the CPU can wait on the video card before it changes the contents of video RAM, because you don't want to change the contents of video RAM while the raster is being drawn, because it'll fuck the screen up. You get snow and funny shit going on, right? So that being the case, we might just be able to use like a 2K static RAM for the video RAM and interface it to the bus the way we normally would with RAM, I mean when it's mapped in, and then the Arduino that would be generating the VGA signal, it could just access that RAM through its GPIO ports when the CPU is not fucking with video RAM. That might do the trick without being nutty. Maybe? I don't know. I just don't think that we can. I don't think we could make interrupt handlers like fast enough, or like tightly timed enough, I should say, to emulate that VRAM inside of the microcontroller. I like something in the back of my head tells me not to trust that to be stable. So an external 2K RAM is probably the way to do that. And then when the Arduino is doing shit, through the emulated CRTC registers, it can just write shit to that RAM. And then when the RAM gets mapped in to the Z80's memory space, everything will be there and ready to rumble. Okay, that ought to work, right? You think that would work? That's actually not quite as complicated as I thought it'd be, but it's still a little bit funny. That'll take some more head scratching, but I think it is eminently doable, isn't it? I think it is. So, yeah, that, we could design boards to make our own kit-based TRS-80 Model 2s that would, you know, mount up inside of an ubiquitous ATX computer case and use an ATX power supply on the back plane. You know, output to a VGA monitor and use a USB keyboard, and then not only would we have, you know, all of the keys necessary for using Xenix more easily than what you'd normally get with a Model 2 keyboard, if we ever got to that point of having like a 68K card in the thing, it would make Model 2s much more accessible to more old computer aficionados, wouldn't it? I think that this is a worthy project, gentlemen. Of course, we want to fix the real Model 2 first, but this was some interesting mental masturbation for this evening, wasn't it? All right. Tell me what you think about all that. Am I completely full of shit? Am I overestimating the complication of this crazy shite? Or I think we can do it, guys. I think we can do it. It may take, you know, some months, especially if we order fucking proto boards from Thailand again. But I think we can do it. Tell me what you think. See you next time, and of course, Merry Christmas.